So welcome everyone for today's session on Python Primer. Today's focus is to kind of introduce you to the key features and some of the new features of Python, which are essential from the perspective of data science or machine learning. Okay, this is of course not a full-fledged Python programming language session. So the objective is to, if you're already familiar with one of the specific any languages, what are the key features and concepts that should be familiar with before we start the actual course, and which are essential or necessary for data science and machine learning perspective. So I have developed two notebooks. We'll go through those notebooks. One focusing on the basic language features and the other one focusing on essentials for data science. Again, the core features of Python, but you need to have a more focus on those basic features and all that. I have already introduced myself, so I'm going to skip this slide. The first is, before I start, I'm going to paste a link on the chat window. So there'll be a GitHub repository, as you can see this. So I'm going to upload all notebooks, data sets onto this GitHub repo now, going forward for all the sessions. Just before one day, I'll uploading all the content, so you can download and store onto your machine. So if you go to this link, which I have pasted on the chat window now, it takes you to the repo called ML course V1. It's under my name, Manoranjan P. It's a public repo. So there is, you can see there's a green button there. You can click on that. Then there's an option called download zip. This will download the whole repo onto your local machine. You can go ahead and download it. Within that repo, there is a folder called PythonPrimer, which contains a couple of notebooks as of now for today's session. And I've given a description of it. We'll go through that again. And I have given a link to the collab as well. I'll tell you why collab. So go ahead and download the zip file for the timing. So I'm going to wait for about a minute here for you to do so. Okay, and once you're downloaded and unzipped, can you just say done on chat window, done or yes or something? If anybody had joined late, I have pasted a link on the chat window. It's a link to the GitHub repo. So go there and download the whole repo as a zip file and unzip it on your local machine. Okay. Once you have done, you can say done and yes and chart window. So I'm not going to continue with the presentation. So let's look at first why Python. This is one of the survey done by Kaggle. By the way, Kaggle is one of the data science platforms uh, where companies and organizations upload their data set and problem statement, and people develop and solutions and upload there. So it's kind of a data science or machine learning competition platform, very widely used. I think quite a few would be already aware of it. So they did a survey and they have been doing it continuously in the last 4 or 5 years. And if you look at, they ask a question like, what programming language do you typically use to the data scientists or ML engineers? So Python has been consistently one of the top languages that gets used by the data scientists. And since 2018, if you look at 19, 20, and 21, in fact, there is a significant increase in the usage of Python. So going forward, there'll be more and more Python adoption, especially in this field. Whether you do the basic data engineering tasks, or whether you do ML tasks, or statistical inference, or advanced things like DL, AI, and all that, right? So Python is going to be our choice for this whole course. So that's why this session is designed to kind of people who are not familiar with Python. Of course, they have to put in some extra effort in the beginning to get used to this language. But it's a very pretty and a simpler language compared to some of the traditional languages, and designed, I would say, for non-programmers, and easy to learn. But of course, you have to put in some effort initially to get familiar with the language. And if you look at also uh, different kinds of roles in the domain, of course, there is not specific role. There are roles like business analyst or data analyst, data engineer, data scientist, even product managers, statisticians, and all that, right? Uh, what kind of language they use mostly? Again, Python comes out to be consistently on the top and most widely used language. So besides, of course, using the Python language, we will also delve into some of the core libraries in the next session when we actually start the data science and machine learning tasks. But besides the programming language, Python and its related libraries for machine learning and data engineering, we will also need a development environment, right? So development environment will help us, you know, organize our code or write the code itself, or develop the solution. So if you look at, some of you might be already familiar with some of the traditional development environments if you're coming from other language or other platform backgrounds and all that, like Eclipse is one of the very popular IDE. So in the world of data science and machine learning, I think Jupyter Notebook is probably the most widely used, right? And of course, there are other development environments like PyCharm is also quite popular. But if you look at again consistently for the last 4 years, Jupyter Notebook has been very widely used, and there is also an increase in usage of Jupyter Notebook over a period of time. Of late, in last couple of years, even VS Code has become quite popular. So we'll also, but in our course, we will actually focus on Jupyter Notebook itself. It's a pretty simple tool. It's a very powerful tool as well. Quite a few features are there. I'll introduce you some of the basic features today, and going forward, of course, in every session, if there is anything specific that you need to learn about it, I will explain that to you as well. Besides, of course, Jupyter Notebook, and Python language, where do we actually write code, whether on a local machine or on a cloud environment, right? So there are two choices, of course, are there. One is, again, if you look at from the trend perspective, the none means basically people were developing mostly on the local machines, and people were also using things like Jupyter Hub, Binder, or Kaggle kernel, and Google Colab, and all that. But again, if you see, look at the trend, the Colab notebooks have become pretty trendy now. I mean, people have been using it, and there's increased usage in Colab notebooks and Kaggle kernels. And of course, people also developing using local systems. I think the complexity of installation, ensuring dependency, version compatibility, resources, and all that have led people to move to kind of cloud solutions. So Google actually provides a free cloud machine called Google Colab, and it comes pre-installed with most of the required software that you would need for some of the data science and machine learning activities. So you don't have to really deal with the installations and all that. But nevertheless, sometimes you might also have to use in local machines. So in this course, I think we'll explore both, how to use Google Colab and how to use local systems also. So I have sent a request to install Anaconda, and my assumption is that you would have already installed that and also learn how to start a Jupyter notebook. So we'll start with Google Colab now, and then towards the end of the session, I will introduce you to how to upload the files onto your own Google Drive and write a new notebook on Google Colab. And also I'll show you how to run those programs or write a new notebook using Jupyter Notebook on the local machine as well. Okay, so I'll introduce you to that concept towards the end. Of course, like I told you, you would have already done the local installation of Anaconda. If you go to the link which I've shared already, if you go to the link, you can download the executables for the respective environments like Windows, Mac, or Linux, and you can install it on your machine. Okay. So today's objective is to kind of introduce you to these features of Python. I have grouped them into three separate buckets. One is the core language features that should be familiar, and the concept wise, of course, you would already know because you would have probably come from some programming background, like variables or conditional statements, control flows, and functions, right? But getting familiar with the Python features or Python syntax is essential here. But the next two buckets are extremely important from the perspective of our course or doing machine learning solutions, right? So you should be extremely familiar with the collections and how to deal with them. So we'll introduce to the four types of collections called list, tuple, set, and dictionary. And I'll also introduce some of functional programming concepts called lambda, list comprehension, and map. Okay, so these are the essential features of Python that you should be very familiar and be aware of it before we get started. Of course, there are some advanced concepts which you'll explore and learn when you go to the specific topic in the course. Again, like I told you, all the notebooks are in the GitHub and will be in the GitHub for the future sessions. So you can pin this or subscribe to this repository. So whenever I upload a file, I'll be keep uploading some exercises in between. So you'll get to know and keep abreast of the repo updates. Okay. For the timing, what I'll do is we'll get started with the first notebook. So if you go back to your GitHub page again, all of you go back to GitHub, the link again, and go to PythonPrimer. So as you can see, there are two notebooks here. One is Introduction to Python Part 1 and Part 2. I have also specified here which are key topics in this tutorial. So that we'll discuss. So first one is introducing the language essentials, and the second one is useful topics from the Python perspective that will be necessary for our course and key for our course. And there are two links here, open in collab on the right. So what you can do right now is the first notebook, right click on the open in collab and open link in new tab. Go ahead and open it. This would require you to log into your Google account or Gmail account, because you'll need access to the Google account. And once it opens up, all right, there is a button here called connect, to see here. So this is going to connect this notebook to a virtual machine. So if you press connect, it's going to provision a machine, a VM with all the required software, right? And this machine will have about I think 13 or 14 GB of RAM and 100 GB of storage, which is all we need for our running our tutorials and exercises. So once you see a green tick button, that means the machine is running. And if you hover around that RAM and disk, you can also see in the bottom, I think the RAM is about 12.6 GB, disk is about 100 GB. So I will again wait here for a minute for you to open the notebook in Google Colab and connect. And once you see a green tick symbol, please go ahead and say done on the chart window, so that you can get started. I'll wait for a minute here. Yeah, looks like I think most of you are done. So I will go ahead and start it. So if you look at the notebook here, and if you click on this three bars here, it shows the table of contents. So there are different topics. You can go to a specific topic by clicking on the link here. But of course, as of now, we're going to go through the whole notebook itself. So these are basically called cells. in the notebook, and in one shell we can write Python code. Either you can write one statement or you can write multiple statements and execute a group of statements. Like you can define a function or a class and all that, and then execute that. You can also write documentation, by the way. To write documentation, we will actually use a syntax called markdown syntax. Again, towards the end of the class, I will little introduce you to markdown. So there's a markdown syntax to write documentation, and typical data science and ML, which is more of a exploratory or ad hoc analysis, we not only write code, but we also document properly step by step what we do, and group the code into different subgroups, right? So in this, so if you want to write a code, you can create a cell with a plus code. You can write documentation, you can create a cell with a plus text, and then you can write documentation using Markdown. So in this particular Python notebook, we will be introducing some of the concepts like variables, print statements, operations, arithmetic operations, conditional statements, control flow statements, dealing with string, and writing functions. So let's start with the first variable. I'm only focusing on the core concepts, and we'll quickly finish this and move on to the next notebook. So when you define a variable, because Python is a dynamically typed language, you don't define the variable types, but it is inferred from the value that is assigned to it. So when you define a variable, you assign a value to it. So to create a variable, assign it to a value and then start using it. So for example, I say var1 equal to 2 and var2 equal to 5.0. Okay. So by the data type of the variable itself, value itself, the data type of the variable is determined. So if I go and execute this cell now, which I can do by pressing this play button here, or you can also use shortcut keys like Shift Enter or Control Enter, depending on you're using Mac or Windows machine. So let's go ahead and click that. For when you start the notebook at the beginning execution, it basically asks for an authorization. You can run anyway. So now if you look at just print var1, is going to print the variable value of var1 2, and if you want to know what type of variable it is now, then you can use something called type. So there's a function called type, which is an inbuilt function. You can pass any variable, it tells you the variable type of it. So you can see the variable 1 has been defined as an integer variable because the value that has been assigned to it is basically is an integer. Similarly, var2 is float. You can also define Boolean variables. var3 is Boolean. So the Boolean values will be either true or false. These are reserved keywords which are used in Python. And then you can also print the value of the Boolean variable. You can also convert the variable types, typecasting you can do. For example, here I'm going to convert this var3 into an integer value. Okay, so that's also possible to do it in Python. But of course, it should be convertible. So let's say you're converting a string to an integer, should be convertible, otherwise it's going to throw an error, an exception. So variables are not statically typed. In a statically typed language like Java or C, a variable is initially declared to a specific data type. So you define the variable to be an integer float and then assign value to it. But in Python, you just assign a value and automatically understands it. And it also allows you to change the value later to a different type also. For example, you can say temp var equal 3.0, which of course initialize the variable to be of type float, but later I assign to a string, which can actually change the variable type to a string also. Okay, so it's also possible. There's also a strongly typed variable that you can define in Python, but not essential from our perspective. In fact, this feature of changing the variable type is not essential, but something that you should be aware of. Now, printing variable values. A print statement is very important because we'll be doing ad hoc analysis and print intermediate results once in a while, or at least from the perspective of debugging, it's an important statement. So let's look at print. So either you can say print a variable, or you can also specify, of course, the string here. But there's also an advanced print function. For example, you want to also print some string literals along with the variables. For example, let's say it's a print value of var1 is comma the var, right? So you can also print like this, which is of course in other languages also there. But this becomes complex, especially when you have too many variables, which values has to be embedded in specific places in the string, right? So for that, Python actually provides something called f strings, which is known as formatted string literals. Okay, where, for example, here what you can do is you can print, and you have to specify f for the f string, and then in double quote you can actually give the string literal, and wherever the variable value has to be inserted, that variable also you can insert with the curly brackets. Okay, so then when you print it, because it is a formatted string, it's going to first evaluate the string, and whenever it encounters a variable, which are typically with the curly brackets, it's going to replace that variable with the actual value that has been assigned to the variable, and then print it. So this becomes a very handy feature, especially to print complex information for debugging and all that. So you can see value of var1 is 2 because var1 is 2, and value of var2 is 5.0. You can also format the decimal places and all that. For example, next one, the value of var1 is var1. Of course, var2 is var2 colon. You can also specify the decimal formatting. For example, here it specifies up to 3 decimal values only. Okay. There are some complex formatting options also there. I will leave that for you to explore further. But whenever a specific formatting required, I will explain at that particular point of time. But just be aware that this is something that is there in the Python as a feature, right? Formatted string, and formatted string with specific formatting options for the decimal values and other values as well. Operations on variables, arithmetic or logical operators. This is something that is, you must be very aware of it. There's no difference here. For example, you can say var1 plus var2, we can add 2 variables, and the resulting variable data type will be the higher data type. If you are adding integer and float, it will always be a float. You can also multiply 2 variables. You can compare by double equal to, right, to a constant value, or 2 variables also you can compare. Okay, this is a very simple feature that essential, and you must be aware of it. Now let's look at conditional statements. We can write if-else statements like in any other language, in Python as well. So the way you write is, you can say if, and there is an expression here which gets evaluated, and the result of that expression has to be true or false, and the expression has to end with a colon always. And then we can give a statement which gets executed if that condition satisfies, right? But if you see here, the code is indented here. So Python indentation is must. Indentation is not optional, okay, which makes the code highly readable in Python actually. You don't need to put in curly brackets, and you can also, if the condition satisfies, you have to execute a bunch of statement, right? Then you can also, write those statements. So from the indentation, it will get to know what all statements has to be executed, right? So indentation is a must in Python, it's not optional. So if you execute this one, now I'll basically say more than one. You can also write if else statements. So if this condition satisfies the expression, print this. Else again colon has to end with the colon, print this, right? So if statement or if else statement. So again, you can have multiple statements here and multiple statements here. Okay, in case you want to do a complex operation, the condition satisfy or does not satisfy. It also provides, so keep executing along with me as I explain each step. It also has a complex conditional statements like if, else. So if this satisfies, print this. Else if this satisfy, print this, or else, right? There can be multiple else if statements specifying different conditions and all that. That can be expressed in the Python. Um, just observe that there's a colon at the end of each expression and the statements are indented. Checking none, which would be used quite few times. For example, I can initialize a variable to none. That means this is almost like a null. Nothing has been assigned yet, just a none. So I can also check if a variable is none, value is none. So where is none? So when I will check whether variable value is none. If where4 is none, then print this. Okay. This is also a statement. This is almost like a plain English statement, highly intuitive. You can do this. Or you can also use something called not none. If where4 is not none, then print this. Okay. So you can do null checking and none checking in Python. Python is the concept of a none, not a null actually. Multiple conditions also you can specify in the if else statements, not only one single conditional statement. For example, let's say there are two variables called math score and English score, 65 and 45. And I say if math score is more than 50 and English score is more than 30, and you can also specify or like and, then result is pass, else fail, right? So you can specify multiple conditions in an expression, and for better readability, you can also, encompass them within round brackets, right? So each statement gets evaluated, true or true, and then becomes based on the and or gets evaluated, and the statement gets executed, right? Sorry. Okay. You also have something called inline conditional statements for simpler expressions. For example, the x value is 11, and based on the value of x, I want to set this particular variable's value to a literal string called even or odd, right? So I can say equal to even if this condition satisfies. So this condition is what? X modulus of 2, which is if I divide the x value by 2, this gives me the residual value. The residual is 0, right? Then I will set to even, else I will set to odd. Right? It's like inline conditional statements, primarily used for very simpler expressions. Of course, we can't use this if there's a complex expression and multiple statements are there. Right? But we will use it widely in a functional programming kind of features, which we'll explore in the next notebook. I'm also giving you some participant exercise. So I'm expecting you to kind of run through this notebook one more time once the class is over, and then you attempt these exercises, right? To kind of get familiar with the those features that I've discussed here. Okay, so we have discussed now 3 or 4 concepts. One is variable and data types, and then print statement, and we looked at something called advanced print function, which is a formatted string, and basic arithmetic and logical operators, and then primarily the conditional statements, if else statements, and inline conditional statements. So now let's look at two more core feature, control flow statements, and dealing with strings, and also look at function, three more features. Control flow statements like a while loop and for loop. I'm going to introduce while here and for loop in the next notebook. While loop is not very widely used for a lot, but anyway, I'm just going to introduce you to the basic structure of while. For example, let's say I initialize the variable I equal to 1, then I say while I less than 10, I'll check if I is odd or even, right, like we did in an inline expression, and I'm going to print that value and say it's a odd or even value, and then I say I plus 1. So first 1, 2, 3, 4 until the value is less than 10, right? So I can actually specify that. So 1 is odd, 2 is even, so on and so forth. And you can see whenever I write a while, you can see that all these lines are indented. So Python knows that if the condition satisfied, until this condition gets satisfied, all the statements has to be executed in each iteration. Okay. Dealing with strings. Strings is something very important variable, and we'll be actually using a lot. You can initialize a string with a single quote, double quote, or triple quote also. There's not much of a difference between single quote and double quote, but triple quote is an important feature where you can initialize strings with multiple lines, right, which is not possible in other languages. You have to kind of say plus and all that, but here you can just take a paragraph and put triple quotes at the beginning and the end, and that is taken as a one single string itself. You can also have a double quotes as a character inside the string, which automatically gets escaped if you use a triple quote. Now, there are some core features that you should be aware of. Inbuilt functions for the strings which are there, which are highly used. I will explore some here, and some more will be later we'll explore. For example, if you want to find a particular substring exists in the string, at what location of the string, you can say string.find, and that substring, it returns the index of it. So the index of course starts always with 0, and then 0, 1, 2, 3, 4, and probably this is starts with 51 or 52. We can also capitalize a string. So capitalized string will do what the string 0, it will basically capitalize the first character of the string. But if you want to capitalize all of them, then you can use upper. Similarly, there is a function called lower as well. You can also look at the length of the string, the number of characters in the string. There's an inbuilt function called length, which can be used across many variable types. We'll come to some of the variables of collections. How many elements in a collection can also be known with the length built-in function. You can also split a string by a separator. If you don't specify any separator, of course, the space becomes a default separator. But of course, you can also provide a specific separator to split it. So string split, this is going to, of course, return all the tokens as a list, as a collection, which of course we'll explore later, what is a list and all that. But in this case, you can see it has split by space, and all the tokens and substrings are written as a collection. You can also replace a particular token or substring with another substring. So you can say replace, if you find a substring called Python, replace it with R. So you can see that substring 2 had a Python at the beginning, which got replaced with now R. Okay. So now let's look at functions in Python, a very important feature, and we'll be defining many functions uh, when you go to advanced concepts. So you define a function with def. This is a keyword. The definition is to start with the def, and the function name and the parameters of the function. Okay. Again, the parameters types need not be defined. It automatically gets inferred when the parameter values are actually passed at the time of invocation. So you say def add elements a comma b, and then it returns a plus b. So once the definition is done, again it has to be indented. You can write multiple statements, whatever it is, and then the last statement has to be return statement. It returns uh, a variable value, or you can also return none, right? So this is the structure of a function. So in this case, it's just adding the value of two parameters that gets passed to this function. So if you invoke now this function add element 2 comma 3, of course we'll get a value of 5. And if you pass 2.3 and 4.5, so in this case we pass two integers. In this case we're going to pass two float values. We'll get back a float value again. Okay. So this is kind of overloading. If you are familiar with the concept of function overloading in object-oriented concepts, typically we define multiple functions with different parameter types, but here overloading is kind of implicit. We don't have to define that. It automatically gets overloaded based on the parameter type it gets passed. Of course, your statements is to support that. Function parameters can also be optional. That means when you define a function and when you define the parameters, some of the parameters you can assign default values at the definition stage itself. For example, a comma b equal to 4. So if b value is not passed at the time of invocation, b can take the value of 4. But if it's passed, of course, gets overwritten. But you can define default values, then b becomes an optional parameter. So at the time of invocation, either you can pass b or do not pass b. It's a very essential feature. You will realize that when you actually use machine learning libraries. So when you build solution algorithms or models, a lot of features would be preset to default values. So if you don't pass them, it takes those default values. If you pass them, of course, it gets overwritten. So if I now call this function with just 2, right? So a takes the value of 2, and b, because we did not pass, it took the value of 4, so it gets added and becomes 6. But if you of course pass 2 and 5, it becomes 7, right? An important feature in Python. The functions can also return multiple values. So when you return something from the function, it not only returns one, it can return multiple values. For example, I define add elements here, a comma b, and I can return a plus b comma a minus b. Right? I can also return multiple values from the function. And at the time of invocation, I can capture those values into multiple variables. Like it's add comma sub. So a plus b value will go to add, and a minus b value will get captured into sub. Okay. Even if you give just one variable, both the values will be captured in terms of a tuple. Of course, we will know the concept of tuple in the next notebook. But you can automatically unpack them, those values, into two different variables here. So now if I invoke this and print it, you can see the add becomes 7 and the sub becomes 3, which is a subtraction of a minus b. Okay. Again, I have given a participant exercise here to write a function. You can do this to get familiar with some of the concepts that we have discussed here. Okay. So quick Recap of the key concept that we saw in this notebook: variable and variable data types, print functions, advanced functions use something called f strings, right? Arithmetic operators and logical operators like a plus, minus, multiplication, and division, right? Logical operators and all that. Conditional statements like if statement, or if else, or if elif else. Also inline expressions, inline conditional statements, we learned that. Control flow statements, we learned only about while as of now. We'll look at the for loop in the next notebook. Dealing with strings, we looked at the strings can be initialized with a single quote, double quote, and triple quote. Triple quotes are typically for a multiple line strings like a paragraphs. And writing functions, right? Writing functions, again, optional parameters, right? By defining default values for the parameters. And we also looked at returning multiple values from the function. Right? Okay. So I'm going to stop here for a moment, and let me know if you have any specific questions, or we can move to the next notebook. Are you all able to execute the code in this notebook?
Yes.
Please attempt the exercise once the class is over. There are two exercises here. So in that case, we will move on to the next notebook now. So you can go to the GitHub link again, and there is another notebook called Introduction to Python Part 2. Again, you can right click, open in Colab. Similarly, you can again connect. Is allocate a VM for you. If you want to close, you can close the previous notebook. So once it is connected, we will look at these four key concepts here. Some of the useful built-in functions that we'll be using in future. Working with collections, this is an important topic. We'll discuss in detail various collections. Some functional programming concepts, and some miscellaneous features. Right. So let's get started with useful built-in functions. For example, some of the math functions. Right. So let's say initialize a variable var with a value of 1.234, and if you want to round it, so the inbuilt function called rounding, which will round the value to the nearest integer. So if you round it, it becomes 1. But you can also round to specific decimal places, like you can say round var1 comma to 2 decimal places, right? So you'll round it to 2 decimal places, it becomes 1.23 now. You can also use a function called POW, which stands for power. So you can raise a variable to a specific power, like x to the power n, right? So variable to the power n. So power, the variable value, n comma the n value, which is 2 here. So basically going to calculate the square of it. So these are inbuilt functions in Python, but some of the functions will come with the libraries. For example, there's a math library there, which again comes with the default Python language itself. So you can import math. So math has many different functions, like calculating log values or cubes, or sine, cosine, tan function, right? Quite significant number of functions are there. So you can import math and say math dot sqrt, square root. Okay, and whatever the square you have calculated, you can pass that variable. So you basically calculate the square root of it. Importing a library has two different options, two different styles. One is you can import the whole library, then all the functions defined in that library can be invoked using this qualification operator, math dot square root. But you can also import specific functions, not necessarily all functions. So you can say from math import only square root. Okay, so square root as a function is defined in this context now. So you can directly call square root square, right? So this is the fashion that gets widely used, the import statement. So normally we always import from the library the specific functions that we need. So if you want to import multiple functions also, you can say from library, any specific library. You can say, for example, in this case, right, you can function a comma b comma c, right? You can comma comma comma. You can import all the required functions. Okay, you will not really need all the functions. You will probably need one or a subset of functions. So always use that style of importing. This also has some implications to the binding to the executables, but that little more detail. Generate a sequence number. There is an inbuilt function called range, which can generate a set of sequence numbers with a start and stop. So you can say starting with 0 until 10, not including 10. So 10 is always excluded. So this value is excluded until this. So 0 to 9 value should be generated. So you can quickly generate a sequence of numbers, and then you can iterate through that. For example, I can say I in the numbers, so I can iterate through that and print the value of I. So I can actually iterate through them 0, 1, 2, 3, 4, 5, 6. And you can also look at the length of the collection. This is basically kind of the 10 elements in that 0 to 9. You can also generate a random number. For example, you can say from random, there is a library called random. There are very different kind of random functions are there. One of them that I'm going to show it here now is random integer. So generate a random integer, anything between 1 to 10, including 1 and 10 both. So if you execute that, randomly going to generate a number between 1 and 10, including 1 and 10 both as well. So if you execute again and again, probably it's going to give you a different number itself. Okay, so quickly we explored 4 or 5 functions: rounding to decimal values, raising a particular variable to a particular power like a square, square root, then range function and random function. Working with collections, this is a very important feature of Python. So we are discussing 4 different collections here. One is list, one is tuple, then set and dictionary. So you can initialize a list. A list is nothing but a collection of elements. It can actually contain heterogeneous type of elements. For example, it can contain one integer, one float, one string, and all that. But most of the times, you will always be having a homogeneous kind of elements. But it can also contain heterogeneous kind of elements, and the elements can repeat. It's not a unique set of elements. Okay. For example, I can say language, a variable, and I can initialize a list with the square brackets. So I can say square bracket and then give each element value, like a C, C++, Java, Go, and Python, all that, right? So now it's a list of strings. I can also initialize an empty list like this with empty brackets, and then later I can insert or append elements into the list itself. So once you create a list of elements, you can access those elements with an index. Now I can say languages 0. The index starts with 0, then 1, 2, 3, and so on and so forth. So I can access the element by the index. I did not expect this. Okay, so C. I can also access a set of elements by slicing. This is called slicing. So 1, 2, 3. That means from the index 1 until 3, again not including 3, right? So this is again excluded. That's how the Python follows. 1 until 3 is always have to read like until 3. So that means the index 1 and index 2. So if you look at index 1 is C++, index 2 is Java. So these two elements in the list. Okay. So now if you do that, it is C++ and Java. We can also use negative indexing. This is a very powerful and simple feature. So Python automatically creates a negative index for all of these elements, 4 and 5. And of course, this is the, so if you say -1, now it's going to return the last element in the list, the Python. So -2 and so on and so forth. You can also use negative indexing for slicing as well, like -1 to -2 or -3, right? That also can do. We can also look at the total number of elements by using this inbuilt function called length. It shows you how many elements are there in the list. We can append new elements into the list using the function called append. For example, append a new language here, Lisp, and you can see that gets added to the end of the list now. And I can also remove it from the list by using the list dot remove, which is going to remove the element from the list. Okay. Now I can also concatenate two separate lists. For example, I'll create a new list called old languages, a basic, Fortran, Pascal, and COBOL, and there's I have a list called languages. So I can now concatenate them. So language plus old languages. So these operators are overloaded to deal with the collections as well, right? So you can simply say plus. Typically we use this operator for a native types like integer, float, and all that, but these are already overloaded in Python to work on lists or collections as well. So now you can see all languages is C, C++, Java, Go, and so on and so forth, right? You can check if an element exists in a list. For example, the substring, the element basic does exist in all languages. It's true, it actually exists, it returns true. Does Lisp exist in all languages? So you can simply say in the basic in languages, basically say false. Okay, this can be actually used in if statement, conditional statement, to check if an element exists in the, and then do certain steps. You can also find out the index of a particular element in the list where it exists. So you can say index Python, it gives you the position or the index of that particular element. So 0, 1, 2, 3, 4. You can also sort it, all the elements if you want. Typically sorting makes a lot of sense, especially when you have numerical values, but anyway, it also sorts by the alphabets here by default. You can also iterate through the list and do certain actions. For example, I generate a sequence of number 1 to 10 and convert that to a list. I can typecast it. So it generates 1 to 9, As I told you, this starts with here until 10. And then I can iterate through it, the list. So if I want to add all the values of it, I can say for I. Remember we looked at while, but in this case, you can directly use for. For I in the nums list. Okay, this is a very widely used statement, the style. So for every element in this list, okay, so it'll take first 1, then 2, 3, 4, and all that, and then I can total it. So total plus I. Okay, so that basically sums up the values. So I can iterate through every element in a list and do certain actions. Of course, we don't use it quite often to sum it like this, but in certain operations we are going to use it. Of course, there's an inbuilt function which is already there in Python, which are again supported for the list. So if you say sum and give the list, automatically it reduces all the elements and aggregates them. Okay. So the powerful inbuilt functions which can be applied to collections as well, right? So this is all about list. Again, list is a collection of heterogeneous elements. Of course, we have explored homogeneous elements only, but can be heterogeneous. But most of the times in real practical scenarios, we always use homogeneous. The elements can repeat, okay, and we can append and remove new elements or old elements from the list. We can do basic operations like concatenating to lists. We can iterate through the list elements as well. Now let's look at tuples. Tuples are again lists only, but they are immutable in nature. So lists are mutable, you can add and remove, but tuples are immutable lists. So once the tuple is created, it cannot be modified. For example, I create a tuple here called topics with 3 elements here: data science, machine learning, and ML ops. 3 elements there in that one. And tuples are initialized with the round brackets. Lists are with square brackets, and tuples with the round brackets. So once I create a tuple, the collection of elements, I can of course access the element by the index. For example, if I say topics 0 like list, it'll return me the data science, right? But if I want to change it, for example, I say topic 1 equal to deep learning, that means whatever the value it is, I'm going to assign a new value to it. Let's say I want to change this value. Then if I execute this, it ends in error. The tuple object does not support item assignment. That's primarily because it's an immutable list. We can convert list into tuples and tuples into list. So we have created one list in the previous section called languages. Let's say I want to convert that to a tuple. So I can simply typecast with the tuple here. Okay. Similarly, I can also typecast, for example, this topics into a list also, right? So I can say list topics. So I can typecast from one form to the other. This of course gets assigned to a different variable, and that you can mute it, that you can modify it. The third one is called set. So set is basically non-repeating items. So it's a collection of unique elements, non-repeating items. So I can initialize a set with the curly brackets. So again, to repeat, the square brackets would be what? List. The round brackets would be tuples, and the curly brackets would be what? Sets or dictionaries also. So we'll look at the dictionaries. Dictionaries are nothing but a kind of set only. So if I initialize B, so 1, 2, 3, 4, 4, I have repeated this item, and 5, 6. But even if I initialize like this, when I look at the B, I only see 1, 2, 3, 4, 5. So it only shows the unique values in the this collection. Of course, I can add new unique value to that. So that gets added to it. But if you add an existing item, of course, it'll only show the unique values. So let's say I have one called one set called B 1 2 3 4 5 6 7. There are another set called 7 8 9 10, two different sets, right? And there are some common item called 7, and rest all are different items. So I can do some basic set operations here. Set operations in terms what? I can say C dot union B. So but that basically combines both the sets, and what are the unique elements across both the sets are now gets added, right? So 0 1 2 3 4 5 6 7 8 9. I can also look at intersection of B and C. What is the common element between B and C? That's only 7. And I can do difference between two sets. But in this case, C dot difference means which element exists in C but does not exist in B. Okay, this would be, of course, different than when I say B dot difference C, right? So this is C minus B, this is B minus C. So how you write is also matters here. So these are of course simple operations, set operations that we typically do. Now let's look at dictionary, the last collection. So dictionary is nothing but a set of key value pairs. It's again a set, but unlike the set where each element is just one element, each element is a key value pair here. So dictionary is a collection of key value pairs. Each key value pair maps the key to the associated values. And you can write something like this. For example, again initialize with the curly brackets here. And you can see this one is an element, this is an element, this is an element, so on and so forth. But each element is a key and value. For example, India colon New Delhi, right? So basically it stores the capital information. So India is the key and the value is as a New Delhi. France is the key and the value is Paris. So key value pairs. And I can access the value by the key here, like a dictionary. So I can say capital India, I can index, now index by the key, right? It returns the value of that new value. Similarly, capitals of Sweden at Oslo, then you realize, okay, Oslo is wrong, then you can change it also. So you can say capital Sweden equal to Stockholm. So now the value gets updated. If the key exists, the old value of the key gets updated with the new value of the key. You can also access the keys and values. Can you show me all the keys that's there in the dictionary? It returns a list. And you can also look at the values as well. You can also add new key values which is not there currently in the dictionary. For example, I can say dictionary China and Beijing. This is almost similar to this updating. So whenever you write a statement like this, it checks whether a key with this name exists. If it exists, it's going to overwrite. If it does not exist, it's going to create a new key and the value. So in this case, of course, it's going to add the new key value pair to the existing dictionary key value pairs. And you can also use something called pop to remove the key values, a specific key from the dictionary. You can say pop China, which is going to return the value of China and also remove it from the dictionary. So you can see now it got removed from the dictionary as well, right? So dictionary is nothing but a key value pairs, and you can access the values by the keys. You can update the key values, you can add new key values, you can also remove an existing key value pair. This is something very interesting feature, of course, you will be using quite a few times. So we'll create a dictionary out of two lists. Let's say I have two independent lists here. One is called the country names, right? And the other one is the name of, let's say, the respective cricket team captains: India, Australia, England, and New Zealand. Spelling slow. And the captains, and of course they are in the same sequence. For example, the captain of India is Rohit Sharma and captain of Australia Aaron Finch, and so on and so forth. Then what I can do is I can create the key based on one list and values in the other list. So there's a nice inbuilt function called a zip, right? It's going to zip them together so that the respective elements are converted into key value pairs. So zip countries, so this values will become keys and this values become values for those keys, right? And convert them into dictionary. So now India, Rohit Sharma, Australia, Aaron Finch, and so on and so forth. Very useful feature, and we'll be using it to look at some of the model outputs and all that. There's a participant exercise here that I have kept here. So please attempt that. And now what we'll do is we'll look at an important feature, right? Lambda functions and all that. So what I'll do is here now, I'm going to give you some 5 to 7 minutes break. So we're going on for 1.5 hours now. And then we'll come back in 5 to 7 minutes and start this. Okay? Is that fine?
Yes, sir.
So we'll be back at, let's say 10:25, 7 minutes. Okay. So we'll discuss now some important features. There are 3 key features that we'll discuss in this section, which will be used frequently going forward. One is called lambda operation or lambda function. The other one is called least comprehension, and third one is called map function. So what's a lambda operation? So lambda basically are anonymous functions, inline functions. Okay. So of course you can assign to a variable which can be like act like a function here. So you can define an inline function like this with the lambda key operator. For example, if you pass a parameter to the function x, right, they return by multiplying itself, basically square value of it, right? So this is how you define a function, lambda operation. Of course, the usage of it will be very clear once we look at a couple of examples. And then you can, of course, assign to a variable like this, and now square, and now you can invoke like square 2, which returns the value of 2 gets multiplied with the 2, the square value of it. Okay, and the usage we will see now. There's something called least comprehension. You can iterate through a collection, especially a list, the single line of code. Now let's look at an example. Let's say if you have a number, a sequence number starting from 0 to 9, right? And I ask you to kind of square these values. So if I ask you to square every element of this list, normally the approach is what? To iterate through them, loop through the elements of the list and square each element, right? For example, I'll define a list called squares with empty list, and then I iterate through every element in the nums, right? So the x becomes 0, then 1, 2, and 3. And then what you do is I can invoke the function square on that x, then append to the squares, right? So I'll iterate through the whole list. First I'll square 1, then 2, then 3, then 4 and 5 and so on and so forth, and append to it and get the collection. Right. So this is the traditional way of looping through collections and squaring it. This is of course has a couple of disadvantages. One is the readability perspective, and second one is this is a sequential operation. There is no real need to square 1 after 0 or square 2 after 1. They can all be processed in parallel, right? Of course, the underlying interpreter has to support it, especially if the system has a multiple cores and it can actually do parallel processing. So to enable that, there are two features. One is list comprehension and map function. So you can write, instead write like this. You can write for x in nums, right? So for every element of nums as x, you can say x multiplied by x. It's almost like inline looping. And the result value should be encompassed into a list, right? So the resulting value, the square brackets are there, and then you can loop through the elements and basically return the value x multiplied by x. So it's an intention to tell that every element of x in numbers has to be multiplied by itself to return the square values. So this also gives you the same result, of course. Okay. Or if it's a complex operation, let's say it's not as simple as just square multiplying with itself, we can define an external function like we are defined here, square, and invoke that as well. In this case, it's still a lambda function, but can be any complex function that you can want to invoke. So it is basically telling that every element of the x has to be transformed through this particular function. So you can use this approach. This typically, this list comprehensions are highly optimized in Python. So there is, because we are not saying that it has to be processed in a sequence, no stateful operations. So the sequence of processing is not typically followed here. Especially if the parallel processing is possible, they can be processed in parallel. Of course, we can't see the much difference in performance, especially when the list is small. But if the list is very large, like in millions of elements or several million elements, you can see a difference in computational time. We can also do the same thing using something called a map function. So people use alternatively either use list comprehension or a map function. Map function as a feature is also extended to other libraries. We will explore some in the other libraries, but the basic idea remains same. So there's an inbuilt function called map, where you specify to map a function with every element of a list. So here the map takes two parameters. They can also multiple parameters, but let's do first two parameters. It takes a function as a parameter first, and then takes a collection as a parameter. And in a way, basically, we are saying that can you map every element of this collection with this function, and then the resulting element can be assigned to a resulting collection. For example, I can simply say here map square and nums. So square is a function we have defined which takes the element and squares it, and nums is a collection. So here saying that every element of a num should be mapped to square, and the resulting value can be can be stored in a C squares. For example, you see here, and if I look at the list, the C squares, the same thing again, right? So this is a much more concise representation of this loop here that we write here, right? So you can always define a function externally and just simply say that every element has to be processed, because you are not specifying as a sequential operation. This has a potential to be parallelized, right? We're just basically saying that every element of this has to be mapped or transformed or processed through this function. So map function allows to process or transform all elements iteratively without using an explicit for loop. You can specify like this a function, or you can directly define it here itself. So this is where the lambda comes very handy. It's a very simple operation, and let's say this function is not leveraged anywhere else. So I can say map lambda x colon x multiplied by x comma nums. So every element of nums now will come as x and gets multiplied by itself, and the resulting element will go to these squares. Now this function, now if you define it here, has no name in it. It's just a anonymous function that's defined only here, and the scope of the function is only within this definition only. This is not used outside. So especially when you have very simple operations, you can actually leverage this expression as well. But if you want to do a very complex operation, then it's always good to define an external function and use it, which I'll show it later. Like map, there's also multiple functions like a filter, which is a very similar function. So filter also takes a function and a collection. Here the idea is to every element will go through this function. If the function says true, returns true, then that gets filtered into the resulting collection. If it says false, then this gets ignored. For example, I want to filter every element in nums. I want to filter every element in the nums if it is even number, otherwise I ignore it. So I just want to filter out all the even numbers. Then what I can do is I can write this expression saying that the nums will go as x, and the x gets divided by 2, and we look at the residuals. If the residual is 0, modulus operation, right? Then of course that element is even number. So equal to 0, it becomes true and returns to the evens. So if I execute that now, you can see on the even numbers here. Give me just 1 second. So either I can define an anonymous function like this, or I can also define an external function like is even, right, which takes an element and checks the modulus is 0, returns true or false, and directly I can invoke like filter is even nums. So every element will go through this function. If it returns true, the element will be stored here. Returns false, it gets ignored, right? So now whether each element will be processed in sequential or parallel can be determined by the underlying implementation of the interpreter. So it is a potential to be parallelized, and this expressions has highly optimized, and if you actually do these operations in very large collection, you can actually see a significant difference in processing time. We can also iterate through two collections simultaneously. For example, this is the first list and this is a second list, right? And let's say I want to divide each element of the first list by the corresponding element of the second list. Then I can also say map a function comma the first list and second list. So you can also keep on going in multiple lists. That's what the signature says, right? The map function signature, map function iterable, right? Then how does it work? Now this function gets two parameters now from both the collections. So the first element of comes as x, the first element of this list comes as y, and then I can divide that. Then second element of this list, second element of this comes as x and y. Then third elements, right? So on and so forth. Of course, the only constraint is both the list has to have same number of elements. And then comes. Then I can divide that, I can see the division of the, right? So these are three important features that are new, yet they're very important features, and we'll be using extensively going forward in our typical data processing or machine learning work. So be familiar with these three features. I given two exercises here. One is to work with collections. So if you go through this exercise, it's a simple one. So it asks us to create three lists, one with the name, one with the math score and science scores. And the math score and science score would be randomly initialized with a random function between 20 to 90. And now you write a function to check the grade. The grade is passed if both the scores are greater than 50, or fail if one of them is less than 50. And then returns a tuple with the total score and the grade. And then create a dictionary with the name and the tuple with the score and the grade. So this particular exercise will help you to kind of get familiar with the creating lists, creating a function. You can actually use for loop here to iterate through all the values. Random function, tuple, and dictionary all combined together. There's an exercise there that you can attempt. The last one is I given a list of dictionaries. So each element in the list is a dictionary itself, and each one contains three keys. One is the date and the open price and close price of a stock. So it's only for 10 days I've given. So out of that, what you can do is you can iterate using either both list comprehension and map function. So I asked to accomplish the task using both the approaches, so you get familiar with both, right? Whether you want to use a lambda function or you want to use an external function, it of course you can decide. And then you can calculate the gain, and the gain can be calculated like close minus open multiplied by 100 divided by open, and the result should look something like this. A dictionary again with the date and the gain for that particular date in terms of percentage, because we have multiplied by 100 here, right? So I have already defined the variable called daily price. You can take that and do basic operations of list comprehension and map function, and I obtain this result. Okay. So that kind of brings us to the end of these two notebooks. I'm going to stop here for a minute and ask if any specific questions that you may have. I'll answer that. Otherwise, I will show you how to run or create notebooks on the Google Drive using Google Colab, and the local system using Jupyter Notebook and Anaconda. Any questions are there so far? So now what I'll show you is I will show you how to write new notebooks on Google Drive, and or execute the existing notebooks on the Google Drive. So what you can do is in the Google Drive, like I have created folders here. You can create you can log into your own Google account and Drive and upload these notebooks, right? Like I uploaded this Python one, part 1 and part 2. And then what you can do is to run them, you can say right click, open with Google Colab, right? You may not see Google Colab if you have not installed yet. So if you don't see it here, you can say connect more apps. See the option here, connect more apps. You can click on that. And then you can search for collaboratory, which will going to show you this Google Collaboratory, this symbol. There is an option to install it here. In my case, it's already installed, so it's showing installed. Otherwise, you install it, and once installed, it will also show you tick symbol saying installed. And once installed, then you can come back again and right click and open with. Now you will see an option called Google Collab, right? And you click on that, you will open it up, right? That's of course to open an existing notebook. But if you want to create a create a new notebook, let's say you want to do these exercises, then in the Google Drive, any space, you can say right click, and like you can create a new Google Doc or form or slides, you can say also Google Collab. Because you already installed it, you'll also show an option for Google Collab. And if you select that, it automatically opens Google Collab now. And you can see an untitled name, so you can give a new name here, like in my first notebook or something, and you can start writing code here, right? This is of course the Python shell. For example, I can say var1 equal to 5.0 and execute it. Now you don't need to authorize because it's your own notebook. Of course, when you execute, it's going to provision the VM for you first. So it's connecting now, then initializing and connected now. So now it got executed. You can see the print var1. Okay. So you can also write text, by the way. So you can click on text and you can write your text here. For writing text, you can use markdown syntax. So for the markdown syntax, if you search for markdown basic syntax on the Google, it'll take to a link called markdownguide.org, which gives you the basic syntax how to write markdown documentation. So how to create a heading, paragraph, line breaks, lists, code, right? Insert images and all that. So it's almost like a HTML page you can write. But of course, you need to be familiar with some of the basic concepts. For example, how to write a header. So to write a header, you can say hash space heading 1. 2 hashes will create 2 headings and so on and so forth. For example, if I go and say hash heading 1, 2 hashes heading 2, and interestingly, it also creates a preview on the right, so you can keep checking. And this is a paragraph, right? And this is a list. You can also create a list like hyphen item 1, item 2, and so on and so forth, right? And once you again shift enter, it's going to create a documentation like this. You can always double click and edit that if you want. So documentation is an important part of data science and machine learning, because you won't be writing only code, you'll be writing the context to the problem, the steps has to be explained, the outputs has to be explained, the inferences has to be documented and all that, right? You can also group the code into different sections for better readability and all that, like I've done in the notebook that I showed you. Then of course you can save it, which automatically gets saved anyway, but so once in a while it's saved. You can also download it to a local machine like a Python notebook, or if you go to a Google Drive now and of course refresh it, you can see the notebook now, my first notebook .ipynb, which stands for IPython notebook, interactive Python notebook. So this is how we can create a new notebook on Google Colab, or you can open an existing one with Google Colab, right? This is similar to what we had done in the GitHub, directly opened it. But if you open from your Google Drive and open Google Colab, any changes that you do to the Google Colab now notebook automatically gets stored here. Okay, you don't have to save it separately. Okay. So Google Colab is something that we're going to use also quite a few times going forward. So get familiar with uploading notebooks to a particular location and open Google Colab, writing new notebooks. Later, sometimes I will also show you how to upload data sets and connect to the Google Colab to read the data sets and all that. Okay. But that's part of a future session. I will show that. Now I'm going to show you how to do it on the local machine. So for the local machine, this is Google Colab. So on the local machine, you have two choices now. One is you can open the command prompt, right? Especially if you're using a Windows machine, you have to open the Anaconda prompt. If you search for Anaconda prompt or Anaconda PowerShell, and then go to some root directory like a C drive or documents in a Mac and all that, then type Jupyter Notebook, all right? Jupyter space notebook. This automatically starts the notebook server on your local machine. It also shows you the URL, which you can copy paste onto a browser to connect to the notebook server, right? By default, of course, when you start Jupyter Notebook, it opens up a browser window. The other option is to go through Anaconda Navigator. You start the navigator and there is an icon for Jupyter Notebook and click on that. Both are fine. And once you do it, of course, it's going to open up the browser window, which may look something like this. Of course, I have, you can traverse to the respective directory where you have stored your files. For example, I have stored here, so I'm traversing here, and you can see the notebooks are here now. So I can click on the notebook now and it opens up on my local machine. Then I can go and execute also here, right? I can go execute, control enter and all that. The same thing I can do it here as well. Or so once you of course run it, it shows it's running. So there is a kernel which gets started to run this notebook, which can be shut down. Once you're done with the job, you can shut down as well. Select and shut down. You can also create a new notebook. To create a new notebook, what you can do is go to a directory where you want to create the notebook and say new Python 3. You will have an option called Python 3. Select Python 3. Untitled. Click on the untitled and you can give it a name like you have done it now. And then save it. And if you come back to your directory, you can see there's a file called myfirstnotebook.ipinb, right? So both Google Drive, the Google Colab, and here they follow the same standard. Now you can exchange and transfer files also because everything is in the same format only, right? We can take from local to Google Colab to local, and all that you can do. And then of course you can go and write code also, right? 5.0 and print the values and all that. And you can also do markdown here, but for markdown what you have to do is you can click on a cell and go to the cell option on top and say cell type markdown. Okay, so now it becomes a markdown cell. By default it's a Python cell, you can only write Python code, but to convert into markdown you have to convert to markdown cell. It's also easy to recognize because there won't be any sequence number here, because for documentation there is no sequence number, only for code there is a sequence number of execution here. So now of course you can write your markdown syntax. All right, this is a paragraph and this is a list. Item 1, item 2 of course doesn't have a preview, but once you write and you can execute, you can see the same documentation here as well. And once you're again done, you can save it and close it. And don't forget to shut down these kernels once in a while when you're not using it, because they are going to consume resources on your local machine. Yeah. So this is how you can either run a local machine or you can also do on the Google Colab. So because I have given you the GitHub location, you can download the files onto your local machine and run all of them and attempt those exercises that I've given, and try something different on your own as well to get used to that. Okay. So that is, I will of course take some questions now, but that brings us to the today's session of introducing Python core concepts, features from the perspective of machine learning. And yeah, so let me open